today, the parts of lesson 3.2 that we're going to cover, come over here to the board with me. Here's our learning goals today. I can determine the domain and range of relations and functions. That's what we'll do on the front side of our notes, okay? And then I can identify functions. That's what we'll practice doing on the back side of the notes. And so when you probably, at least about the only thing you maybe got read through when I asked you to start reading this is the beginning here where it says a relation is a set of ordered pairs. So if you have a set of ordered pairs, points on a graph, any set of ordered pairs, we're going to call them a relation. The relation can be in the form of a table. So like here we've got one given into us as a table, or a graph. Here we have one given to us as a graph. Or a mapping diagram, and here we have one given to us as a mapping diagram. We'll practice that tomorrow, making them, displaying them in either a table, graph, or mapping diagram. Today, on this side, what's really important is that we're going to understand for a relation, what is the domain. So I want you to box that sentence right there that says, the domain is all the x values. So we have this set of ordered pairs, and we know that all ordered pairs have an x value at the beginning of them and a y value at the end of them. We have two coordinates identified in an ordered pair. So if we take the x's from those ordered pairs, from those points, they make up the domain. Then I want you to put another box around, well, what's the range then? The range is all the y values. So we're going to take the y values from the ordered pairs, that second number in the ordered pair, the y value of the point, and those are going to make up the range. So they have some examples up here for us just to take a look at, in that where they displayed the relation as a table. They said, find the domain and range. Here's how we're going to write them. Okay, I want you to put a box around this. This is going to be how, when you have to write the domain and range, we're going to show it in set notation. And we're going to use capital D for domain, capital R for range. And notice, so after capital D, they have a colon, and then they use these fancy little brackets, which are kind of, tricky to make, but here's kind of like a little hint how to make them when you don't know how. It's like a parenthesis with a V on its side with another parenthesis. Okay, that's how you make those. So you start the set with one of our brackets, and then we list the x values, and notice in this one it says do not list 2 twice in the range. Well, we don't have, so here's our x values for the domain, 3, 4, 5, and 6. So we have to list each of those to show that in the domain you can have an x value of 3, you can have an x value of 4, an x value of 5, and an x value of 6. And then in the range, and then we close our set with our notation. And in our range, capital R, colon, we have a 1, we have a 2, another 2, and then a 3. We do not repeat that 2 in the range. We just say the y values that can be in the range are 1, 2, and 3. We do not have to state that 2 twice. Okay? So the domain makes up it's all the x values, the range are all the possible y values. Let's go on to this one where this is called a mapping diagram. We're going to do this a little bit different, so I'm going to have you cross it out, and we're going to state this differently than they did. Okay? So cross that out, and let's instead do it again down here below. We're going to state the domain and the range in numerical order from least to greatest. And again, we're not going to do any repeats. So what would be the first member of our domain from that mapping diagram? By the way, we map x's over to y's. So the first oval are all the x values, and the second oval are all the y values. The x's are mapped to the y's. So what would our domain be in numerical order from least to greatest? Abby? 0. Okay, 0, followed by 2, followed by 7. Okay, that's how we're going to state them. In numerical order from least to greatest. Okay, so it's still the same domain, still has the same members, but we want them just in a different order. How about the range? Do we need to change the range? Is it in numerical order from least to greatest? Yeah, it is, so we're going to leave the range as it already is. Okay, so look at our next one when it comes from a graph. And what kind of a graph is that? Is that continuous or discrete? That's a continuous one, isn't it? It isn't just distinct points. There's a whole bunch of points on that line segment. So that's connected from one end to another. Okay, here's what I want us to do. First of all, I want us to put a point at each end. And I want us to write the ordered pair name for each of those points. Right on the graph. Okay? What is the ordered pair name for that point that's at the top of the line segment? At the top end of the line segment. What's its ordered pair name? 2, 5. Has an x value of 2 and it has a y value of 5. Okay? What's this one's ordered pair name? 7, 3. Okay. So here's the deal. Whenever we have a continuous, those other two would actually be discrete graphs. If we graph them, they would be discrete. If we have a continuous graph, we can't name every individual member of the domain or every individual member of the range. So we have to write them as inequalities, as compound inequalities, in fact. So let's look at what they did here. And we're going to actually put our little brackets around these also. So get some more practice putting those on. Notice what they said, the domain. Remember, it's made up of x's, so x is our variable in the middle of our compound inequality. The domain has to be between 2 and 7 because that's our smallest x value. 7 is our largest x value. Every other point on that line has an x value somewhere between those two. So they included the equal to bar so that we would have the endpoints also. So this says x is greater than or equal to 2 and less than or equal to 7. So if we graph that on a number line, when we'd graph it like this, we would say, oh yeah, 2, 7, all the points in between and include 2 and 7. And that's exactly what's going on there. It's just that it's at a slant rather than horizontal. Okay? And then the range. The range is made up of y's. So we look at the y values and we say, oh, the smallest y value is 3, and the largest y value is 5. So we write a compound inequality that has 3 is less than or equal to, notice the variable is y this time because range is made up of y values, is less than or equal to 5. Okay, we're going to go down here and practice all of those types. Okay? Number 1, what would be the domain, capital D, start our set notation. What would be the domain for this one? Noah? Numerical order, least to greatest. Okay, -2, -1, 0, 1. Y'all agree? Can we go with that one? Okay. How about the range? Aurora, what would the range be? Numerical order, least to greatest. Another hint, no repeats.
0, 1, 4.
Okay, good. 0, 1, 4. Least to greatest, no repeats needed. Okay, you guys try number 2 now then on your own. That's, instead of giving them in a table, they're giving them as ordered pairs, and we know that ordered pairs are made up like this. So what would the domain be and what would the range be? Calvin, what's the domain? Least to greatest? Numerical order? X values? How about Julia?
-5, -2, and 4.
Okay. Thanks, Julia. Okay. And now range. Range are the y's and numerical order least to greatest, no repeats necessary. Devontae.
5, 6, and 12.
5, 6, 12. Okay. Those are the correct domain and range for it. Okay, anybody questions so far? go to the mapping ones then, 3 and 4. In 3 and 4, we have map diagrams. Remember that x's are mapped to the y's. X's are mapped to the y's. So what's the domain? What's the range for each of these? Okay, let's start here. What's the domain? Cody, what's the domain for this number 3?
0, 2, and 3.
0, 2, 3?
Or 0, 1, 2, 3.
Okay, so we have to include all of them. We just don't have to do any repeating. So 0, 1, 2, 3. Range for this one. Michaela?
5, 6, 7, 8.
Yeah, we start with 5, 6, 7, 8, so that they are from least to greatest. Okay. Tori, domain for number 4. Least to greatest.
-5, -4,
Okay, -5, -4, -3. Abby, range.
10, 11, 12, 13, 14.
Okay, here we go. So any questions on the ones that are discrete? These are discrete relations. If we were to graph them, we would have distinct points on a graph. We would not connect the points. Any questions on the discrete ones before we move on to our continuous? Okay, these are the challenging ones. These tend to challenge students more than the discrete ones do. Okay, what are we going to do? We're going to identify the endpoints first of all. What's the ordered pair name of each of those points? So take the time to do this when you're doing your homework. Also, it will help you be more successful. So what's the ordered pair name for this one furthest to the left on the graph over there in quadrant 2? What's its name? -2, 1. Okay. How about the other one over there in quadrant 1?
2, 4.
2, 4. Okay. So remember, we have to do compound inequalities, and they're and. So we're going to do domain. What variable are we going to use our compound inequality for the domain? We have to use the x. Okay. So it's going to be an and one. So I can tell you right now, you can do this much. It's going to be an and type. It has to lie between these two, and it can include these two. So we're going to put the equal to bars there also. Okay, what is the smallest x value that's going to be on that line segment? -2. What's the largest x value that's going to be on that line segment? +2. So the x values, they start out at -2. They don't go any further to the right than +2. There's our domain. Range. That's our y values. It's a compound and inequality again. What's the smallest y value on that line segment? 1. What's the largest y value on that line segment? 4. So y has to be somewhere between 1 and 4. When we look up and down, and it can include 1 and 4. Okay. On this one, we got 4 points to identify. Let's start up here at this, let's start here at this one in quadrant 1. What's that one's name? 2, 1. Okay. And the other one in quadrant 1, what's its name? 2, 3. Everybody do this on your graphs. Okay, over here in quadrant 2, what's this one's ordered pair name? One at the bottom. -3, 1. And the one above it is?
-3,
3, 3. Okay. Go ahead and try to write the domain range for this and see how you do. Right on your own. What's the domain? In other words, what are the values x has to be between and including those values? And then once you get the domain, go ahead and try and move on to the range and see if you can get the range for it also. Okay, Noah, what's the domain?
-3 and 2.
And 2. Okay, so it goes no smaller than -3, but it includes -3, and it goes no larger than +2, but it includes +2. Everybody agree? Okay, how about the range? What's the range then? Aurora?
1 and 3.
Okay, so it doesn't go any smaller than 1, and it doesn't go any larger than 3, but it includes them both. We all agree? Okay, good job. Anybody have questions on domain and range when you're practicing this in your homework? Anything that still you're not quite sure what you need to do? Okay, let's go to the back side then where we have to work with functions, okay? Now, because we are kind of running out of time here, the only thing we're going to talk about is, first of all, its definition. I'm going to leave this for you to study, and I want you to take time to study it on your own, because this is one of those things that is a hard concept to understand. When is a relation a function? It says a function is a type of relation, so a function is always a relation, but not every relation is a function. Because here's what has to be true. Each x value, and I want you to start putting a box around this, each x value, each domain value can be paired with only one y value, one range value. And it's the x that controls the situation. So x, every x, each x can only have one y. Okay, so let's go down here and take a look at number 7. Tell whether this relation is a function and explain. So in other words, you will either say something like, yes, it is a function because each x value has only one y value, or you'll say, no, because this x value, when x equals this, it has these different y values. Okay, so what do you think about number 7? We have an x value of -2. Does it have more than one y value? What's its y value?
1.
1. Is there another -2 for x in that table?
No.
No. Is -2 repeated?
No.
No. Okay, how about -3? Does it have more than one y value?
No.
Actually, it does, because here it is, it's repeated again. There's where x is equal to -3, and look at what happened. We have 2 different y values. So right there, it breaks down. It's not a function. So we're going to say not a function. This is a relation. It's still a relation, but it's not a function. It's still a set of ordered pairs. We're going to say when x equals -3, 2 different y values. It can't have that. It can only have one y value. It cannot have 2 different y values. So we're going to be specific. When x equals -3, there's a problem. There are 2 different y values. Michaela?
During homework, we just put non-function energy loss.
So I want you to explain too, just like we're doing here. Okay? So in your homework, you're going to not only say it is a function, but it is not, but you're going to explain. How about number 8?
Yes.
Okay, when x is 4, what's y? 5. Okay, let's write those ordered pairs over here so we can have a look at them. We got ordered pair 4, 5. What other ordered pair is in that mapping diagram?
8, 5.
8, 5. When x is 8, it also has a y value of 5. Okay, how about another ordered pair?
12, 10.
12, 10. And we have one more ordered pair, and there it is.
16, 15.
16, 15. Okay, let's take a look. When x is 4, our y is 5. Okay, is there ever another time that there's an x equal to 4? No, so when x is equal to 4, how many y values does it have? Only one. Next one, x is 8. When x is 8, what's its y value?
No, 5.
5. Is there any other time that there's an x equal to 8 in that group, in that relation? No, okay, so it only, when x is 8, it only has how many y values? It only has 1, that's all it has to have, as long as it just has 1. How about when x is equal to 12? Y is equal to 10. Is there any other time that there's an x value of 12?
No.
No, so when x is equal to 12, there's only one y value. How about when x is 16? Our y value is 15. Is there any other time x is equal to 16? No, so then when x is 16, it only has one y value. Is this a function?
Yes.
Is a function. And we're going to say each x value has only one y value. Each x value has only one y value. That's the rule it has to meet to be a function. Okay, how do you feel about number 9? Is that a function? Let me do something for you because we're running out of time here. Let's do this. Let's put a point here and let's put a point right here. So put a point up here at the top of our triangle and put one down here at the bottom right here. What are the ordered pair names for those points? What's this one's ordered pair name? 3, 3. Okay. What's this one's ordered pair name?
3, -1.
3, -1. Okay. So when x is equal to 3, what's y equal to? 3. And
-1.
-1. Can x equal to 3 have more than one y value and be a function? No, so we would say this is not a function. Not a function. And we're going to say when x is equal, we're going to pick out a time that makes it not, this is not the only time, but we only need one. When x equals 3, there are 2 different, and that's important to say, 2 different y values. Okay? So those are the types of things you're going to be dealing with in those problems that you have over there in the homework. So you really don't have time to get your loosely up and write down your heading so that you'll be able to do it. And use your notes as your guide to make sure that you show enough support for your answers. Okay? Anybody have any questions that you need to ask me?